and I would like to invite Dr. Miquel Pitarch Mocholi to join me on the virtual stage. And Miquel Pitarch Mocholi is a cooling and policy expert from United for Efficiency at UNEP. How are you doing, Miquel? Nice to see you.
Hello to everyone. Nice to see you. Thank you very much. Yeah.
Thank you. So I'm really keen to learn how well-designed policies are driving the transition to more efficient and low GWP cooling and heating equipments. The floor is yours.
Yeah, thank you, Julika. I'm trying to take over the presentation, but now, okay.
We have
hello.
Yes.
Hello to everyone. It's a pleasure to be here today with all of you. And I'm going to talk. I don't see the slides that are for me here, or should I pass all of them, or?
Just wait for some seconds because we have
Okay.
to re-enter the presentation at your specific slide.
Okay.
And if you want to, you can start talking, and meanwhile, we are transferring our presentation to the beginning of your presentation.
Okay, perfect. Now, I'm going to talk about the role of policies in advancing to energy efficiency and lower GWP technologies for the cooling and heating sector. As Julika was saying, I work for United for Efficiency, which is an initiative of U4E. And the goal of U4E is to support countries on the implementation on the market transformation of energy efficiency lighting, appliances, and equipment. And we do that by implementing what we call the integrated policy approach, by supporting countries on the standards and regulations, but also on the environmentally sound management, monitoring, verification, and enforcement, and any other supporting policies that will help countries to make this market transformation. Here in the left, what we can see is the potential savings from implementing these kind of policies for different products and for the 156 developing and emerging economies around the world. So if all these countries, they implement the energy efficiency recommendations from United for Efficiency, we will expect to have annual savings in 2040 of more than 900 terawatt hour per year. And this will be equivalent to avoid more than 800 million tons of CO2 equivalent from the indirect emissions of the energy consumption. And we look at the 6 products here, where we have distribution transformers, motors, commercial refrigerators, domestic refrigerators, lighting, and air conditioners. We see that the air conditioners are the ones that has a higher potential for this energy savings. And in addition to the savings from the energy consumption, we have also potentials for avoiding CO2 emissions from the refrigerant side, because air conditioners and heat pumps, they also have refrigerants inside, right? So if we look at the kind of policies that we can implement for energy efficiency, we have 2 main policies that we work with. And this is the minimum energy performance standard that I'm going to call from now on like MEPS. And these MEPS, what they do is to set up a minimum level of efficiency, and all the products that are below this level, they will not be able to enter into the market. So we are banning from the market that products that has a really high energy consumption. And then the models that are above this level of efficiency, we can use the energy efficiency label. So the consumers, they can compare the different models, and they can make a better decisions when they are selecting between different models of air conditioners or heat pumps. And then when we look at the refrigerant side, we can also implement policies to accelerate the implementation of the Kigali Amendment in in this matter, because if you look at the GWP, the global warming potential of different refrigerants that are used in the cooling and heating sector, we have, for example, the R410A, which has a global warming potential, a GWP of 2088. And if you compare this with another alternative, that is the R290, this has a GWP of 3, and this is the propane. This is a natural refrigerant, and it's already a feasible alternative to the R410A in many applications, right? So by setting also limits to the GWP, we will be banning air conditioners that has a high GWP, and they will not be able to enter into the market. Okay. And then so in addition to the support that we give to the individual countries and regions to implement these kind of policies that we were talking before, we also have international guidelines that they are available in our website. So every institution or countries, they can use them to have like a basis that are based in best international practices, and they have been reviewed also by many international experts. And we have guidelines about the model regulations that talks about the MEPs, the labels, and the refrigerants, but also for sustainable procurement, which includes also other types of requirements. We have the country saving assessments for the 156 countries, where we can see the different energy saving potentials. And we have also other tools, such as the product registration system, which is a really important tool for the implementation of the policies. So all the manufacturers and importers, they should introduce the parameters of each model of air conditioners that are going to be introducing the market before they introduce them in the market, right? So we have a prototype for this product registration system that can be adapted for the needs of different countries. Okay, so here what we have is a map with the global status of MEPS implementation for air conditioners. We can see in green those countries that already have MEPS, and in blue the countries that are in progress. So they are working on the implementation of the MEPS, even though they don't have them yet. We can see that there are many countries that they already have MEPS, and this demonstrates how countries see this as a really potential tool for saving energy. However, I have to say that some of these countries, maybe they are not enforcing as much as they should these MEPS, so they will not be getting the expected savings. So it's important not only to publish and implement the regulation, but also to really enforce the regulation. And then there are some other countries that they are enforcing and they have MEPS, but these MEPS might be out of date. So it's also important to update the MEPS from time to time, because technology is advancing, and to continue to have an impact on the market, we need to update the MEPS and the labels for the different products. And as an example of this, we can see here the Asian region, where you see that many of the countries, they already have MEPS, but they are working now on updating their MEPS. And U4E has been supporting the Asian region to publish the energy efficiency roadmap for air conditioners, which was published in 2021. And the recommendation was to align the energy efficiency limits, the energy efficiency requirements, to the U4E model regulation guidelines. And then after this date, countries, they started to work on the national implementation of the recommendations. And for that, U4E has been supporting at the national level Singapore, who has already published and who is already implementing actually the recommended MEPS values from April 2025. And U4E is also supporting Malaysia, who is already implementing new MEPs, but in this case, they will be implementing the recommended values in several steps. So next year, in 2026, they will be enforcing MEPs that are below the recommended values. But then in 2030, automatically, they will be updated to the recommendations, to the recommended values. Okay. And this also is an example of how the recommendations, they can be adjusted to the needs of different countries, for example. And then we have also Vietnam and Philippines, which are also working on the recommendation implementation. And for this, GSET is the one that is supporting at the national level for the implementation. And this update of the MEPs for air conditioners in the Asian region is not only important at the regional level, it's also important at the global level because it has a really high potential for energy saving. Because they are hot countries, they use a lot of air conditioners, and switching to a more efficient appliances, they will be saving a lot of energy and avoiding a lot of CO2. And we can see this here in this graph in the left, where we can see the annual saving potential of the 10 countries in the region. And this is a study from 2022. So we can see that from 2022, these energy savings are growing every year. And this is because every year we are replacing the old air conditioners with newer air conditioners that are much more efficient. So every year you have more and more annual savings in the cooling sector. And then here in the right side, we can see the annual saving potential for 2040 for all the 10 countries. That is more than 140 terawatt hours per year. And this will be equivalent to avoid more than 110 million tons of CO2 equivalent. And also will be saving more than 17,000 million of US dollars. And of course, since we have less energy consumption, so we are producing less energy also, and we could be avoiding the construction of 66 new power plants of 500 megawatts each power plant. So it's a huge saving potential for the region. And of course, if we look at the cumulative savings for all the years, these numbers will be bigger. So yeah, hope you learned something new with this presentation. Thank you very much. Yeah.
Thank you very, very much, Miquel Pitarch Mocholi. Thank you, thank you. And for those of you who joined us for the previous sessions, you know that right now we are not going to answer your questions directly, but we'll move on to our next presentation, and after that you will have the chance to ask your questions directly. What you can and may do is use the chat for placing your questions and then highlight them, and we can come back to that later. So thank you again, once again. And with that, I would like to invite Dr. Ana Luiza Dutra, who is Associate Economist at the International Finance Corporation, who later on will be joined by her colleague, Dr. Denis Medvedev, who is Chief Economist for Global Industry at the IFC. Welcome, Luiza. There is a change of plans because from now on we are going to share the presentation, and I would like you to just tell us when to move to the next slide. All right, so welcome, Anna, and the floor is yours.
Thank you, Julika, and hello everyone. I'm really excited to be here today talking about finance for sustainable cooling. So I'll share findings from the Cooler Finance Report. That was a flagship publication that was issued last September as a joint effort between IFC, UNEP, and the Cool Coalition. So as I'm sure many of you will agree, sustainable cooling is a pressing issue of our times. We have global greenhouse gas emissions rising every year. They're driving extreme heat, and they are leaving vulnerable populations struggling to survive and without ways to cope with what's to come. So to respond to this, we need massive scale up of access to sustainable cooling, and for that we need finance. Next slide. So I'll discuss our findings from the Cooler Finance Report, which focuses on the finance challenge for sustainable cooling. So the report was structured to first talk about market sizing for sustainable cooling across emerging markets and developing economies, then look into challenges and response strategies, and finally to provide financial solutions and innovations. Next slide, please. So I'll start by going over our market sizing exercise. So you can click. So right now, the market for active cooling in developing economies is valued at $272 billion per year. You can click. So space cooling in particular is a huge market. It is the biggest segment and it accounts for almost 50% of the total cooling market. And looking ahead, we also expect to see a large growth. So the cooling market in developing economies is expected to more than double to at least $600 billion per year by 2050. And what's driving this growth is a combination of factors, right? So it includes rising populations, increasing incomes, urbanization, and all of that on top of increasing temperatures worldwide. So all of these are pushing demand for cooling, and especially space cooling. Space cooling is the fastest growing segment, and in fact, it is expected to almost triple in size, so to grow from $129 billion in 2023 to $332 billion by 2050. Next slide, please. Yes, so far, I've only talked about active cooling, but one of the most important pieces in getting to net zero emissions, and which is also essential when we're talking about sustainable cooling for buildings, is passive cooling. So passive cooling is all about reducing the need for active systems in the first place, so both at the urban and at the building levels. It's a market that's much harder to estimate because the costs are usually hidden within the building's design and the benefits can be hidden too. But from our estimates today, the passive cooling market in emerging economies makes up about 10% of the total cooling market, with around $15 to $25 billion per year in new buildings and $10 to $15 billion per year in retrofits. So this market is really small, but it needs to expand dramatically if we want to deliver on the near zero emissions that were described in UNEP's Global Cooling Watch report. And to get to that, it will depend on having a fast pace of adoption and enforcement of building energy code across countries. If we do things right, by 2050, the new builds market could reach $150 billion per year. Next slide, please. Okay, so investing in sustainable cooling is not only justified because of its environmental and development impact, but also because it makes sense economically. So in the report, we consider scenarios in which we accelerate the adoption of high efficiency equipment and also increase the use of passive strategies, and we compare that with our benchmark scenario. And we find that it could lead to around $8 trillion in cumulative avoided costs in developing economies by 2050. So that happens through reduced electricity costs for consumers, savings in new active cooling equipment for consumers as well, and also in avoided investments in power infrastructure. If we look only at the effect from increasing the use of passive strategies, that alone could generate cumulative avoided costs for consumers of $4.6 trillion by 2050. Next slide, please. Okay, so far, the estimates that I've discussed only account for those that will need cooling and also can afford it. But it leaves behind a significant number of households, SMEs, farmers, and so on, who either need cooling now or will need it in the future, but they don't have the financial means to access it. What we did is that we used household survey data and estimates on SME finance gap to calculate the cost of closing this cooling access gap. So we estimate that up to $800 billion is needed to ensure access to cooling to everyone who needs it. So we actually get this estimate as a range based on two extreme scenarios. So we assume a lower bound, where we assume that the space cooling needs are met using fans, and an upper bound where we consider that they are met with air conditioning. But in reality, we know that we'll need actually a mix of solutions, right? So including fans, air conditioners, and most importantly, passive strategies. So for residential space cooling, our cost estimates range from $8 billion to $372 billion in gaps. Also, $172 billion gap for refrigeration in homes, and the $268 billion for SMEs for space cooling and refrigeration. Next slide, please. Okay, so this analysis gives us a good understanding of the investment opportunities, but we also need to understand why investments haven't happened already. So one of the main messages that we have in the report is that private finance is essential for the cooling transition, but finance is not enough. We know that cooling cuts across many sectors, so we really need the right enabling environment for action. So that includes having national cooling plans and other public policy instruments that help to coordinate between different agencies and also to bring in the private sector. And it also includes other crucial drivers, such as reliable electricity access, mature supply chains, innovation, new business models, and urban programs that help communities respond to rising temperatures. So for all of these reasons, we treat cooling as really an ecosystem where we need to have multiple levers of supply and demand working together to drive action. So one example of a response strategy targeting space cooling in buildings is IFC's EDGE tool. So EDGE is an analytical tool that identifies resource-efficient design measures, and it estimates what are the costs and the return on the investment. So EDGE always first recommends passive energy efficiency measures before moving on to active ones. And buildings that get EDGE certified can also qualify for favorable green finance terms, making it easier to unlock investment. Next slide, please. So finally, there are different business model and financing solutions for sustainable cooling. And our message here is simple. So when it comes to financing sustainable cooling, no size fits all. So the design of the business model and the financial instruments must really respond to the financial needs and characteristics of providers and consumers, and also consider the local context, including the capacities of the financial sector and the risk appetite of the financiers and investors. So that's why we don't take a prescriptive approach in the report. Instead, we highlight a broad range of financing solutions that can support cooling and be scaled up. So some of these are adapted from other sectors, while others are tailored specifically to cooling. So you see a few examples listed here on the right, and I invite you to explore the report for more detail, including some case studies that show the application of these solutions. And go to the next slide. Thank you so much. I invite you to go to the report and reach out if you have any other questions.
Thank you very much, Ana Luiza Dutra, for your insights. And please, everybody from this session, rejoin us on our virtual stage. We would like Dr. Miquel Pitarch Mocholi to join us. And if you want to, Dr. Denis Medvedev as well. And we are open for our Q&A session right now. So use the chat, write down your questions, raise your hand, and I can see your questions. All right, let's give them a second to organize themselves and write down their questions in the chat or raise their hands if they have a question. And while we're waiting, maybe I would like to start with the question. No, there is the question. Wonderful. We have a question right now. And it comes from Matatela Ntsatsi. Please, the floor is yours.
Okay, thank you very much. I just have 3 points maybe which I didn't understand well when they were addressed, especially concerning the financial issues. I was trying to spot out which are the potential financial supports that we, the developing countries, can access, especially to see on how we can be able to assess those finances. Because the understanding is that, yes, it's true that we have seen on how far the other countries have done. But we felt if you could have, maybe this is a potential that you can apply, and this is how you can be applied. You can apply for. It could really help, because we have more interest in cooling plan, carbon finance, also in research that includes the issues of prototypes that we can be supported. I think they can help me. Maybe I couldn't realize those points. Thank you very much.
Thank you very much. So that was the question for resources and funds. Who would like to get to that question? Miquel, maybe you?
Well, from the financial side, I don't know that much. I'm more technical expert from the maps and label side for energy efficiency and so on. But if I understood correctly, the question how to implement this, like carbon credits and the savings from that can get from the energy savings and so on. So we are working, for example, in a project where in Nigeria and Ghana, where we will be working with financial mechanisms and rebates to support like consumers to get like R290 air conditioners and really high efficient air conditioners. And of course, when you invest on this kind of rebate and financial mechanism to support consumers to buy these kind of appliances, you can also obtain carbon credit from this investment as an institution and so on. So maybe countries that wants to apply like carbon credits from this side, they could also support consumers on purchasing this kind of high-end and high energy efficiency and low GWP refrigerant equipment. Yeah.
Thank you very much. Anna, would you like to add, or should we move to the chat?
So perhaps to add on the financing bit, of course, there are a number of solutions that are available. Some of them, we discussed in the report that Anna was presenting. I don't want this, and I don't want to make it too much about IFC, because I think we're talking about solutions by all kinds of organizations, but certainly, one of the programs that IFC has in this particular space is called Tech Emerge, where we've funded, together with support from some of the donor governments, a lot of new innovative models. So there's, the type of financing ranges from kind of grants and equity type of financing that goes to innovative companies that operate in the space, all the way again to the work that IFC has done with larger financial institutions in terms of different kinds of bonds, whether it's general green bonds, whether it's specific, whether it's green mortgages to support green buildings. So there are a number of initiatives there that do specifically benefit developing countries to implement these sorts of initiatives. There are other, of course, multilateral, bilateral institutions that also are engaged very actively with developing countries to build the market for these kinds of things. As Anna explained in her presentation, of course, because there's so many levers, it's difficult to talk about one or two initiatives. I mentioned a few examples, but the market is much broader. What I think is clear is that we do need to grow the overall size of this market, as well as pilot different types of financial instruments that respond to particular challenges.
Thank you very much. Let's move on to the chat. I have a question directed to you, Miquel. So how does the CSPF value translate into European split ACs? MEPs is 4.6 right now.
Yes, there is not like a direct conversion from one metric to another one. Especially for the European Union, because the CSPF also can vary also depending on the weather table that you are using for different countries. So in my presentation, it was there were some values for the CSPF, and for those values of the CSPF, we were using the weather table that is by default in the ISO standard. So, but this ISO standard, they can be used by another country, and they can change to a different weather table, and they will be getting different CSPF values. And from weather tables that are used using the ISO standard, is easier to convert. To the European Union, it's a bit more complicated because they are using also different test standards, not only the weather table, but also different test points and so on. So it's a bit more complicated. I cannot say you this is 6.1 in the European, 6.1 of CSPF in the ISO standard is similar to 4.6. I cannot say you the exact conversion, yeah, but the 6.1 that we are recommending, they are based on best international practices in MEPs that has been implementing in China during these last years. So, and in China, they are using the ISO standard, so it's easier to make this comparison. Yeah.
Thank you very much. We have two more questions directed to IFC. One is, does the 272 billion in 2023 refer to active cooling measures only? Yes. And if yes, do you have estimates of what the passive cooling market size in emerging markets would be in 2050?
Yes, so the 272 is active cooling alone, and then we have the 30 billion estimate for passive cooling, for passive measures today. We do not have an estimate for the passive cooling market by 2050 because of as I mentioned, it's a much harder market to estimate, and by getting to 2050, we don't have any projections on the building codes and all of those advancements, so we do not make those because of all the uncertainty involved.
Thank you very much. Second question to IFC, are there already funding lines which cover passive and active cooling investments?
Yes, so I think Denis mentioned a little bit already on the funding on his previous response, but we do have those initiatives, such as one of our biggest initiatives was the Tech Emerge, which was focused mostly on innovation. And there are, as I mentioned, for instance, for the EDGE buildings, if you get EDGE certified, that helps you get access to green finance. And there are also a lot of other initiatives with other multilateral organizations and all that.
Thank you very much. So the chat is running, which is really nice. Just want to remind you, if you see a question that I really should ask, give your thumb up, okay? Because we have only like 4 more minutes left. And if you vote the question you want to get an answer to, let us know. All right, we have a question. What precautions should be taken when replacing an HFC air conditioner with an R291? Space, the presence of electrical or electronic devices, electrical outlets, and closed spaces. So the precautions with propane.
Yes, yeah, yeah, I can answer that one. Yeah, so yeah, everyone is really worried about propane sometimes when they start to introduce air conditioners with propane. We have already electrodomestics like the refrigerator also already has R600A also, which is also hydrocarbon, also with A3 level of flammability. Of course, we have less refrigerant inside. So for the air conditioner is a bit more, you need more precautions. So at the end, you need to follow the safety standards during the whole process, during the manufacturing of the air conditioner. So all the equipment inside is prepared so there are not sparks that could start like a fire or things like that. And then you need to follow also the standards for the installation of the air conditioner, not only for the manufacturing. And here is where it comes the electrical outlets and so on. So for example, for the electrical outlet, you cannot just install the indoor unit just above one of the electrical outlets. It needs to be a certain distance. I don't know the exact details, but I think it's the ISO 5149 is the one that that tells you how you need to install all the air conditioners with flammable refrigerant. Yeah.
And once you do that, what's your take on using propane once you've taken all the precautions necessary?
Yeah,
Are we good to
I guess
go?
is like the refrigerators before. People was scared about R600A refrigerators, and now everyone has R600A refrigerators at home because there are safety standards that if they are followed, it is safe to use them. So for the air conditioners will be the same. We need capacity for technicians, of course. We need to follow the safety standards, and this is not built from one day to another, but it's been a while already that the R290 is out there, and countries are advancing on having all these capacities and for the implementation. So, and now with the new F-gas regulation, I also see a faster implementation of this type of air conditioners. Yeah.
Exactly. Thank you so much. Regarding the revised F-gas regulation, we have a question around the definition of sustainable cooling for you, IFC. So what role do refrigerants play in IFC's definition of sustainable cooling? Is the IFC's definition aligned with the Kigali Amendment, or does it go further and align with the EU revised F-gas regulation? Does the IFC take PFAS into account when defining sustainable cooling?
Yes, so our definition when talking about sustainable cooling, so we align with the definition from the Global Cooling Watch. So that says that sustainable cooling technologies are accessible, affordable, and scalable, and minimize environmental impact, and also with the goal to achieve near zero emissions by 2050. So as shown in the Global Cooling Watch report, in order to get to that, we need to have this phase down of HFC refrigerant at a faster rate than what's required under the Kigali Amendment. Yes. You're on mute.
Julika, you're still muted.
Yeah.
Yes, thank you so much. So our last question would be, at present, more or less, passive strategies are funded with approximately 11% in relation to the funds available for active cooling. What do you consider the 2 or 3 most important steps to change this?
So maybe I could start and then Annalisa can complement. it's hard to sort of say what are the 2 or 3 most important things, because obviously it's all context dependent. This said, I would really encourage everyone to start thinking more about the demand side of the issue rather than supply, right? So instead of thinking about how much funding is available, let's think about how do we generate more demand for passive cooling. And for example, the report will get into some of the details of that. Obviously, that has to come, for example, from the regulatory side. We need to have the regulations that make it easier and that promote the adoption of passive cooling. We also need, on the architect side, for example, architects who know about passive cooling strategies and who actively suggest it to their customers, right? If they don't do that, that market is not going to move. We need consumers themselves who understand the importance of passive cooling, and again, who ask for it in terms of buildings, whether it's residential or commercial. So I think the demand angle is probably underestimated. If we make a lot of progress on the demand side, I think we will see a lot more adoption, and the financing will follow. There are many instruments that are not exclusively dedicated to either passive or active. They're more aimed at improving the adoption of sustainable cooling periods. So I feel like a lot of that money will become fungible once we see growing sustained demand for passive cooling strategies. And of course, it's also important to recognize that those are more likely to happen in new builds. Not all the time. There's some passive strategies that can be applied equally, but particularly as we build up new areas, the understanding the importance of passive strategies is going to be really a key driver there. Anna Luiza, anything to add?
No, I think you said it perfectly, and just to reinforce the point on new builds, that yes, it is much easier to have these passive cooling strategies in new builds than to have retrofit later. That's much more expensive.
Thank you so much. Miquel, do I detect your eye movement correctly, that you are reading the chat? So if you want to reply to something that is worth mentioning to you, please do so, and the same goes to you, Anna Luiza and Denis. Last chance to add some comments, clarifications, or answers. Miquel.
Sorry now. Yeah, I was reading the question about the safety precautions and things like that. Of course, we cannot go through all of this, but tomorrow we are going to have another the season 6, so maybe we can talk more about this kind of things tomorrow. Yeah.
Exactly. This is what we're going to do. Anna Luiza, Denis, are you ready to wrap this session up and to say goodbye to this year's Green Cooling Summit? I guess
yes,
you
I think
are.
so, and we're just very thankful to you and the team for giving us the stage to talk about this report and this work, and really encourage people to continue engaging on this topic.
Thank you very much, and
yeah,
once
thank
again,
you very much. Yeah.
Thank you, Anna Luiza and Miquel, for your presentations. And with this, we are going to wrap up our first day. Give some reactions to our presenters, to our speakers. Leave some hearts, some reactions in the chat. Thank you so much.